Hello, this is Seán Mullery from Electronic Engineering in IT Sligo, and in this short lesson I'll be explaining to you why we need computer languages and why in particular we will be doing the C programming language. So, the three slides that we'll be looking at in this show are firstly talking about what a computer understands. Then we'll be looking at what the need is for a higher level language, and I'll be explaining to you what higher level languages are. And then finally, in the final slide, I will be explaining to you why we've chosen to use C in this particular case. So, firstly, to think about what a computer understands. The first thing you need to know is that computers are not intelligent. Many people think they are, but they are in fact not intelligent. They are very, very simplistic machines, and they cannot think for themselves. They can only do what they are programmed to do by a computer programmer. So they can only understand very simple instructions, and by very simple instructions I mean they can move data around, they can add data, they can subtract data, and sometimes they can do multiplies and divides as well. But almost anything beyond that, they have to do lots of combinations of these simpler instructions in order to do something quite complex. Okay, so they always do it by breaking it down into very, very simplistic things that they do. These instructions, the instructions that that the computers can actually deal with, they must be coded in binary. Remember, computers are made up of very large numbers of transistors. Okay, very miniaturized transistors, and a transistor in this case is used as a switch. It's just on and off. And so it can only understand two states, on or off, or as we sometimes call it 1 and 0, and so on. And these are the binary states. And therefore, for a computer to be able to take any information in, to act upon it, and to send information out again, it must be in a binary form. I've given an example of a binary code there where you can see it goes 1001, 000, 111, and I've just made up that code. It doesn't mean anything specific. But the point is that even if it did mean something specific to a computer, it's very difficult for a human to make sense of that just by looking at it when it's only ones and zeros. It's not in a form that makes sense to a human. So it is very difficult for a human to interact with a computer on the computer's terms. Okay, and hence that brings us on to the next thing, which is the need for higher level languages. And these are languages that bridge the gap between the human and the computer. Lots of examples of these. I've only shown a small few examples here. C obviously is the one we're going to be doing. C++ is another one which was built on top of C, but it is a different language. It's not the one we will be learning here. Java is another example which is very much based on C and C++, but it has significant differences in the way it's implemented, but based on the same languages. C# is another one. Then there's Basic and Visual Basic. Fortran is another example, Python, JavaScript indeed, and JavaScript and Java, by the way, are not the same. They only share the first two syllables in common. But again, all of these are computer languages that are a little bit easier for humans to understand and then can be converted into that binary code that the computer understands. And so they're set up in that way to make them easily convertible. So the goal of all these languages is to bridge a gap between the human and the computer. The closer the language is to the computer, the harder it is for the human to get things done. So we have these languages known as assembly languages, which very much deal in the different little instructions, give a name to each of the instructions that a particular microchip or computer can achieve. And then you have languages like C and so on, which are quite close to the computer in how they're actually in how the language works. C, for example, only has 32 specialist words that it uses, and the rest must be made up by functions and so on around that. But then you have other languages like Java and Visual Basic and so on, where you can drag and drop things and write a little bit of information behind that, or you could write the whole computer code behind it. But a small instruction or sentence can do a huge amount in some of these languages like Java and Visual Basic. But the problem is that when you get to the likes of Java and Visual Basic, which are much closer to what the human can understand, it's that bit more difficult to turn it into something that runs really efficiently on the computer. So the kind of interpreter or the compiler has to do a much harder job to try and turn that into something that runs really fast and uses up very little memory. In fact, it doesn't do that very well. And so that's what brings us on to the reason that we would use C. C is not a particularly easy language for the human to get things done. It can take you much longer to actually write a program to do something that you're trying to do in C than it can to do it in some of the other languages like Java or Visual Basic. It certainly doesn't look as nice because in Java and Visual Basic and those sort of languages, you can write lovely graphical user interfaces. You can do it in C as well, but it takes absolutely ages to do that, whereas you can do it very, very quickly in Java or Visual Basic. However, C is extremely efficient, and it's because it's so close to what the computer can understand. It's very easy to just make that small modification to get it from the C code into binary code. So this makes it harder for the human to achieve things, certainly, but what they achieve is very, very efficient. Now, what you have to remember is that on this course, this is part of an electronic engineering course, so we're electronic engineers, and our goal is to write programs that use up as little memory as possible and execute as quick as possible. So they must be very, very efficient. We're not concerned with writing software products like Microsoft Word or something like that, which can take up huge amounts of space, and as long as if it's going to take up more space, we buy a bigger computer. In our case, we're generally dealing with software that the person never sees. It's the firmware that goes into the likes of your DVD or your Blu-ray player, or it might be something in a mobile telephone. And as such, it has to run really efficiently. It has to run with very little resources, so very little memory and so on. And it also, with a lot of the battery-driven appliances that we have now, it should use up very little power. And of course, every time you execute an instruction on a microprocessor, that uses up power. And so when you write something in C, you can also you also immediately get that efficiency gain in terms of the amount of energy that's going to be used if it runs more efficiently. That's not to say that you can't write things badly in C, but certainly when you want to write something very, very efficiently, it's the best language to do it compared to some of the other languages. So that's why we use C. It's because we're electronic engineers and we want to write programs for embedded systems to be more efficient. So just do a quick roundup and just remind you of the things that I said at the beginning. I talked to you about what a computer understands, and that they're not intelligent, that they only understand binary code, and they can only do very, very simplistic instructions. That's why we need computer languages to get us to bridge that gap between the human and the computer. And finally, I said that we use C in particular because it's quite close to the computer. That makes it harder for us humans, but it does mean that we can write very, very efficient code for the computer, which is what we want to achieve in this case. Okay, thank you.